What's up, math magicians? This is section 3.2, solving quadratic equations by graphing. And so we're going to do, the central question really is how many solutions does each equation have? And you're going to use the related graph of each equation to answer. What do I mean by that? Well, if you were trying to solve just x squared plus 2x plus 3 equals 0, what you really could do was pretend you were graphing it. Like stick an f of x equals on the front of it, ignore the equals 0, and when you graph it, you can see, it has 0 x-intercepts. Therefore, the original equation you started with, it has 0 solutions. Same thing over here. Let's say if you wanted to solve this, you would need to look at the x-intercepts. And so you could graph it. F of x is equal to all that. And you see, oh, here's an x-intercept. Here's an x-intercept. There's 2 of them. Therefore, there's 2 solutions. 2 x-intercepts, 2 solutions. And what about this one over here? You could graph it. F of x is equal to negative x squared minus 8x minus 16. You could throw that into your Inspire onto Desmos graphing calculator, and you'd see that it touches just barely as tangent to this x-axis at exactly 1 point. There's one x-intercept and therefore one solution to this equation. The big idea is that solutions and x-intercepts are very related to each other. So graphing becomes incredibly indicative of solutions. So what you could do is solve each equation by graphing. So for example, so here we can see these are the 3 equations that we're going to have. And for this bottom one right here, there's just so many negatives. If you multiplied all the terms on both sides by -1 and make it easier, the calculation's easier. You can just do x squared plus 8x plus 16 equals 0. Now, if you're in a situation where you have to graph this by hand, you would do an input-output table, and you would even find that the vertex, you could put the row that represents the vertex right here in the middle by plugging in, identifying A as 1, B as 2, C as 3. And so h is going to be negative b over 2 times a, which turns out to be -1. Boom, there's -1, there's positive 2 as its output. And so the vertex is here at -1, comma 2. But really what we're looking for is, we're looking to figure out what the solutions are to this original equation. We took this x squared plus 2x plus 3 equals 0, and we put it as in function form. F of x is equal to all this, and turned it into something we could graph. And when you turn it into something you can graph, you can solve it very easily by looking at the x-intercepts. But there are no x-intercepts here. There's 0 x-intercepts, therefore 0 solutions. And boom, you're done. So if you wanted to solve this equation right here, you can turn it into f of x is equal to this equation right here, ignoring the equal 0. You graph it, you figure out where the h value is, boom, and then you can see right here at -2 and positive 5, you get y values of 0, which is really, there are x-intercepts on the graph, but they're also the solutions to this equation. What are the solutions to x squared minus 3x minus 10? They are -2 and positive 5, because we can see them on the graph. What are the solutions to negative x squared minus 8x minus 16? Well, you could multiply all the terms on both sides by -1 just to make the calculations easier, and then stick an f of x on the front and graph it. You all know how to do this. You can graph it. You can find that the h value right here, this -4, is going to be negative b over 2a. And therefore, when you're graphing it, boom, you get that, and then you can see there's this parabola only has one x-intercept. It is at the vertex, -4, comma 0. So therefore, the original equation only has one solution. This solution is -4. Here, regularity. Use a quadratic equation to find 2 real numbers that satisfy each situation, or to show that no such numbers exist. So, that's 2 numbers of the sum of 4 and their product is -17. What are the 2 numbers? Well, I don't know what the numbers are. We'll call them x and y. Very important to choose letters from the alphabet on this one, because you can't write equations without it. So when the sum is 4, it looks like this, and when their product is -117, it looks like this. Let's do some substitution, because you can get y all by itself right here, and then plug it into the blue equation. So x is no longer times y, it's times what y is equal to. 4 minus x is equal to -117. We're going to set it equal to 0, and because I'm sensing that a quadratic equation is coming. The way we solve quadratics is we set them equal to 0. Set them equal to 0, and then y is equal to, or f of x is equal to x times 4 minus x plus 117. You pull out the graph, you graph this, and you look for the x-intercepts, and they're at -9 and +13. That's how you could do it, using a graph. Physics. Love them physics. So use the formula for height, a -16 t squared plus v0, the initial velocity of t plus the initial height. Mela throws a baseball with an initial upward velocity of 32 feet per second. Oh, this 32, that's going to be the initial velocity right here. The baseball is released from Mela's hand at a height of 4 feet, which is right here. Use a graphing calculator to determine how long it will take the ball to hit the ground. Well, you can take these 32. V0 is 32 feet per second. H0 is 4 feet. And what we don't know is the t time when h of t is 0. So we use our formula. We put 32 in here and 4 in here. And then you can graph it. When you find the t-intercept, which is the same thing as the x-intercept, it's going to be about 2.118. Again, here you find that you can plug this into a graphing calculator. On the Inspire, it would look like f1 of x is equal to 9 minus 1 divided by 50 x squared. But then you look at that graph and find the x-intercepts, and you get x is about plus or minus 21 yards on either side. Radio telescopes, again, look at the graph. You can take this entire polynomial and put it in, and you get your x-intercepts. It's about -7.0, and x is approximately 57.0 meters. This is where the locations for the what's the diameter. The question is, what is the diameter, solved by graphing. And so if it's just the distance. When you're finding the distance between 2 points on the graph, you can subtract. 57 minus -7 is a total of 64 meters apart from each other. Volcanoes. A volcanic eruption blasts a boulder upward with an initial velocity of 240 feet per second. Again, initial velocity is 240. That's there, and then there's no initial height. It just starts at ground level, 0. How long will it take the boulder to hit the ground if it lands at the same elevation from which it was ejected? Initial height is 0. V0 is 240 feet per second, and then we want to know when h of t is equal to 0. So we graph it, and you can see it's about 15 seconds. And that's all, y'all. Very short video. We've got some Inspire stuff coming. So pull out those Inspires, and I'll see you in class.